So, good day everyone. My name is Gladys Venus Corpus and I'm going to be your reporter for today. So, my topic is all about double mass analysis, mean areal precipitation, depth area duration analysis, and frequency analysis. So, let's start with the double mass analysis. Double mass analysis is a common use data analysis approach for investigating the behavior of records made of hydrological or meteorological data at a number of locations. It is used to determine whether there is a need for corrections to the data to account for changes in data corrections procedures of other local conditions, so such as changes of result from a variety of things, including changes in instrumental, changes in observation procedures, or changes in gauge location or surrounding conditions. Double mass analysis for checking consistency of hydrological or meteorological record is considered to be an essential tool before taking it for analysis purpose. This method is based on the hypothesis that each item of the recorded data of a population is consistent. So, example of double mass analysis. So, double mass plot or double mass curve for this point and or adjoining line are plotted where the x and y coordinates are determined by the running totals of the values observed at the two stations. So, if both stations are affected by the same extent by the same trends, then a double mass curve should follow a straight line. A break in the slope of the curve would indicate that the conditions have changed at one location but not at another. So this technique is based on the principles that when each recorded data comes from the same parent populations, they are consistent. So here are a sample graph of the double mass analysis. So hydrologists use double mass analysis to confirm the consistency of the precipitation or stream flow report. So, precipitations of a station is plotted against the combined precipitation of the surrounding stations. The consistency of the file is verified if a single straight line outfitted through the points is cheap. So the analysis is carried out on the laptop via becoming a directly line and a 4 diploma polynomial through the point and comparing the two sums of square of the deviations of the factors from the fitted curves. If a report is located to the inconsistent, it is far adjusted by the means of bringing the deviated factors along the served single instantly line. So the technique needs to be a fee to the hydrologist having access to the computer system. So next we have the mean areal precipitation. So precipitation in a specific area expressed as an average depth of liquid water over the area. The average depth of precipitation over the specific area calculated on the time scale of a storm, seasonal or annual basis. So hydrologic requirements for aerial estimates of precipitation. So the river forecasting fashion in use with the aid of the NWS requires aerial estimates of precipitation. This is due to the fact that the fashion stimulates rainfall runoff techniques on the drainage catchments area foundations. So massive river basins are subdivided into these smaller catchment or runoff zones. So runoff from extra precipitation in every sector is used to calculate stream flow, which is then used to supply river degree forecast. So, estimation of aerial precipitation. A single factor precipitation size is quite often now not representative or the extent of precipitation falling over a given catchment place. So, a dense network of point measures and or radar estimates can provide a higher illustration of the genuine volume over a given vicinity. A network of precipitation measures by converted the aerial estimates using any of some of the strangest, which include a strategist, which includes the subsequence. So here are the mathematic. So we have mathematic suggest here the aerial precipitation estimate is calculated with this method as the arithmetic means of the 5 stations points measurements considered in this. This approach calculates aerial precipitation using arithmetic means of all factors of aerial measurements considered within the analysis. Second one, we have isohatal evaluation. So, isohatal analysis methodology. So, A, draw lines of equal precipitation. B, estimates precipitation in each grid area within basin. So, C, sum the values in each grid area. D, divide the sum by the number of the grid areas to obtain a basin aerial estimates of the precipitation. So, last is aerial estimates is 1.9 inch in this case. So, isohatal evaluation, that is graphical method which entails drawing estimated traces of identical rainfall over an area primary based on a point measurement. So the significant and the value of the resultant rainfall regions of coverage are considered as opposed to the vicinity inequality, which will estimate with the aerial precipitation fee. So next we have Tyson polygon. Tyson polygon, that is some other graphical approach which calculates station weight based at the relative areas at each dimension station within the Tyson polygon community. The person weights are accelerated with the aid of the stationary mark and the values are summed to reap the aerial average precipitation. So next we have distance weight graded. So distance weighting or graded is every other station weighting method. A grid of factor estimates is made primarily based on a distance weighting scheme. So every observed factor fee is given a unique weight for every grid points based on the space from the grid points in question. The grid factor precipitation fee is calculated based totally at the sum of the individual station weight elevated through determined station as soon as the grid points have all been estimated. Their sum and the sum of is divided via wide variety of grid factors to achieve the aerial average precipitation. So next we have MAPX, that is a NWS unique graded technique. Aerial runoff zone precipitation estimates are made the usage of the 4 times 4 kilometer WSR 88D 1 hourly graded precipitation estimates. The arithmetic imply calculation method is used to common the grid factor estimates. So next we have index station. In a few regions of the country or ordinary mountains regions, predetermined station weights primarily based on the climatology are used to compute basin average precipitation. So aerial precipitation terminology as utilized in ADRFC hydrologic modeling. So we have imply area precipitation, aerial runoffs, region precipitation estimates normally based on factor precipitation observations. So the space weighting calculations technique is used. MAP or MAP is used as input to the river forecast version on an ordinary foundation. MAP-X, radar-based, totally means aerial precipitation area runoff. Region precipitation estimates primarily based on the 4 times 4 kilometer WSR 88D 1 hourly gridded precipitation estimates. The arithmetic mean calculation technique is used to common the grid factor estimates. MAP-X is used as enter to the river forecast model on a ordinary foundation. So FMAP, future imply aerial precipitation destiny or forecast aerial runoff zone precipitation estimates. The weather forecast offices or WFOs develop precipitation forecasts based totally on input from resources which may additionally encompass meteorological version output, national steerage, merchandise, nearby forecast techniques, and individual forecaster revel in. So next we have depth area duration analysis. So depth area duration analysis is generally as the catchment area increases, the especially average rainfall depth for the catchment falls. Data on the depth of rainfall for the storm is commonly presented as tables or graphs showing maximum average depth of storm rainfall over different areas and is called the depth area duration or DAD or DAD. Once the enough rainfall records for the vicinity are amassed, the simple or raw fact can be analyzed and processed to supply useful data inside the form or curve or statistical values to be used inside the planning of water resources development project. Many hydrologic troubles requires an analysis of time as well as aerial distribution of storm rainfalls, depth, location, duration, or DAD. Analysis of a hurricane is carried out to decide the most amount of rainfall inside diverse duration over areas of numerous size. So last but not the least, we have frequency analysis. So flood frequency analysis is a technique used by hydrologists to predict flow values corresponding to specific return period or probabilities along a river. So the application of statistics frequency curves to floods was first introduced by Gamble using annual peak flows data that is available for a number of years. Flood frequency analysis is used to calculate statistical information such as mean, standard deviation, and skewness, which is further used to create frequency distribution graph. So thank you very much.